This is a detailed training video for a Showmark ErgoSpooler optical fiber and fine filament and wire winding machine. We're going to go through every aspect of it in detail. It should be enough information to operate the machine once it's delivered to your premises. So with the help of Ed, we're going to go through setting up the machine and just explaining each part of it. Starting with, mounting a spool to the take-up section. But let's look at the parts of the take-up before we actually do it. So, here is the take-up, and you can see that it includes a chuck for mounting a shaft into. It'll accommodate any shaft from 0 to 10 millimeters in diameter. In this case, we always provide the machine with a 10 millimeter stub shaft that Ed just put in there, along with a set of spool adapters that he's got in his hands, and we'll look at that in a moment. And this stub shaft is convenient because it allows you to put a standard Corning or some other manufacturer's spool of fiber on there right out of the box. The chuck also is very helpful if you've got unusual spools or mandrels you want to mount on there with a very small shaft. So he's putting the spool on, and here he is. You can see these are easy locks, and it's a spring-loaded device in the front. The back cone that is hidden by the spool right now is fixed in place. Its position is adjustable by loosening it and retightening it, but it doesn't move now. But now Ed will slide on the front easy lock. You want to push it all the way on and then turn the outer ring to tighten it in place, and that will prevent the spool from spinning on the shaft. And if you're winding with no more than 100 grams of tension, then there's no need to tighten that too much. If you're winding with very high tension, then you probably do need to tighten down a little more. Taking the spool off, yeah, there you go. Why don't you take it off? It's actually a little trickier. You need to unspring that front collar to allow it to be backed off. And it's actually very easy to do, and Ed makes it look easy, and it is, but it takes a little getting used to. It may be the hardest part of the machine to operate, but it's actually pretty easy once you've done it for a while. There you go. Show off. Okay.
We're going to leave it loose till we...
Yeah, right. We always leave it a little loose until we are finished pulling the fiber through the machine. But let's look a little more at the payoff section. So you can see in the back, I don't want you to point, there's a servo motor that will be turning the spool, and that motor drives through a gear head. Then the whole assembly is carried by a servo motor driven traversing unit. That's a ball screw traversing unit, very high precision. You can see the servo on the back side there. All right. Before he threads it through, why don't we look at the rest of the machine? This device here is what we call an alignment array, and the fiber will be threaded between these two fiber optic sensors. Ironically, they're fiber optic and we're winding fiber optic wire, but that's just a coincidence. But there's two sets of fibers there that create a window of detection, and the machine will automatically keep the fiber between those two sensors all the time while it's winding, and the purpose is to keep a straight path of travel at all times, which helps prevent twisting and stress in the fiber. So the traverse on the payoff will move automatically based on the feedback from those two sensors. Okay. The fiber will then travel through our length tracking assembly. We call this the LTR, stands for length tracking roller. Thank you, Vanna. Mm-hmm. And these are nice spinning, very smooth surfaced anodized rollers, and the actual length tracking is done by this blue polyurethane roller, it's got a groove in it for keeping the fiber captured. I don't know if you can see that. And this roller is coupled to an optical encoder on the back side. And it's a high-res encoder. I believe this one is 1,000 pulses per rev, being read through quadrature, so it's literally 4,000 pulses per turn of this wheel. So it's a very high resolution tracking that the machine does. And we resolve that down to a micron on our screen. Fiber travels downward from there to our tension transducer, and that's a solid state device. There's no motion from that. It's just got a strain gauge in it, and we calibrate that for whatever tension range the customer wants to use. In this case, this machine is set up for 100 grams max. You can't wind down to 0 grams. You'll get a range of about from 10 to 100 grams total with the machine, usually with plus or minus 2 grams of stability in the winding. If you don't get carried away with too high a speed, that is. Okay. So then fiber travels up to our dampening sheave, and the purpose of that is just to absorb any fluctuations in tension, usually caused by a badly wound payoff spool, that there might be some crossovers or plucking of the fiber as it comes off there, and that spool just, I'm sorry, that wheel on the spring-loaded slide will absorb any fluctuations in the tension. Then it goes down from there to just a guide wheel that then routes it back up to our final guide arm that's got a few small, very low inertia guide wheels on it. The last one being that very precise V-groove roller. That's a 1-inch diameter V-groove, and that's your final guide point before the fiber goes on to our take-up shaft, which we'll get to. So Ed will mount something to wind onto on that shaft. And you can see here, it's similar to the payoff. Again, there's a chuck, and we've got a stub shaft. That's a 10 millimeter diameter shaft. And again, we supply that with easy locks. And he's going to mount this small 4-inch diameter spool on there. And really for that spool, that's all you need. But if you want, there's also a sliding tailstock here that can be used to support the end of the shaft. In this case, it probably isn't necessary, but if you had a very long coil you're winding on there, this machine, for instance, can wind up to a 250 millimeter long spool or mandrel or something, a sensor body on there. In that case, you may want to use a tailstock for sure to support the free end of the spool or shaft. And again, similar to the payoff, there's a servo motor turning it in the back and also a servo driving the traversing unit down below. And you can see our complete take-up assembly there that supports the tailstock end as well. And as the name implies, the ErgoSpooler, this is where the operator is intended to sit while they wind. Ed, why don't you take a seat real quick in that chair? So he'd be there monitoring the winding as it occurs. He can make any corrections if needed. He has complete control with a foot pedal. He can control the speed, reverse if needed, make a correction, but also he's there if he needs to perform some operations such as applying an adhesive or just inspecting or marking the fiber as it winds, or just there to take the spool off when it's done. So the machine's off right now, as you can see. Why don't we power it up and start from scratch. So here you turn your power on for the main machine, and then there's also a computer down below which you need to turn on. Just a standard PC down there. think that's an i5 from Dell. And that will fire up our monitors. So you can see there's two monitors there. The lower one is our touchscreen operator interface, which will come on in a moment once the computer boots up. And the upper screen is going to be displaying images from this digital camera that's stationed above the coil. Yeah. So behind each screen, there's your power buttons. For the touch screen, you can see the buttons back here. Oop, thank you. There's your power right there, and other adjustment buttons. And then also there's power button for the upper screen there. But the truth is, it'll just come on. We keep it powered all the time. It comes on with the PC. So Ed just turned on the touch screen. Or he turned it off. We'll see. Wait, give it a second. Is it red or green? There you go. Okay. So it came up with our main operator screen there, which we'll go through in detail in a little bit. Should probably get the camera going as well at first. So I want to point out that the upper screen is not a touch screen. So the icon to turn on the camera is a dyno capture program right there. And there's literally a mouse that we provide with the PC. And you have to use the mouse to double click on that icon. So yeah, if you can just use that shelf. It's a little awkward, but you only need to turn it on once. This is why we don't let Ed run the cameras. Okay, there it is. You can, Ed, you can maximize just that upper button up there if you can get to it. Yeah, if there were a mouse pad around, it'd be easier. Okay, so that turned on the camera capture software, but to also turn on the light source for the camera, that's mounted right there on the frame. There's a button down there. There you go. So now the camera's on, and we'll be using that in a moment, a little bit. There's an adjustable light source on there that he's playing with. But we'll get that set up once we have some fiber on there. Okay. So now we'll thread the fiber through. But you know what? Before we do that, we want to show the inside of the cabinet. Just get that out of the way. We'll do that. Nah, the camera's pretty good. So we're just going to use a screwdriver to open up the latches. Okay. Looking inside, one thing I see right off the bat is we need some covers on our Panduit, which we'll do for sure. But inside, it's a pretty neat control package and pretty simple too. The main brains and muscle of the system is right there, which is a 4-axis motion controller from Galil. And that not only is the brains, but that also contains the 4 amplifiers for the servo motors that are in the machine. And so there's a lot invested in that one component right there. All the motor wires and the limit switches for the traversing units come into the terminal blocks and wire into the Galil there too. That green unit right there next to the terminal blocks is the strain gauge amplifier for the tension sensor, and that's where if any calibration is needed for the tension, you can do it right on there. It's upside down right now, but you can see you have, no, it's not upside down, I'm sorry. You can see you have settings for the 0 point
zero setting as well as the upper calibration point, and you have a fine and a coarse setting for each one. That's a little blurry, I apologize. And then down below here you have a breaker for the main breaker for the machine, and there is a fuse for this power supply, which is a 48 volt supply that powers the servo motors that are in the Galil or being run by the Galil. And then that extra power supply is for any other devices on there that needs a 24 volt supply. So that's the inside, pretty simple. Now that we've gone through the parts of the machine, we'll go through the operator interface. And this is the main screen that comes up when you do start the program. In addition to this main screen, we have a recipe screen, a system settings screen, and a report screen. And we'll get to those as well. But starting here, you can see, I don't know if it comes through on the camera, but the screen is divided into sections. You can see these gray borders here, hopefully. But here we have a section for controlling the take-up motor that turns the take-up spool, spins it. We have controls for the take-up traverse. We have controls for the payoff traverse. And here's where we set the tension. And then in the center section, we just have a series of buttons that we'll go through in a little bit that will determine whether we're winding from left to right on the take-up spool or right to left. And then a few other buttons that you push as you're proceeding through a recipe. Here are the parameters that will show up when you do load a recipe or enter one. The values that you're trying to maintain for this job will be shown there, and then the real-time information will show right here. The last section is where you actually initiate the motions, whether it be winding, unwinding. You can pause. If you get an error, which can happen, you clear that with the reset button. And then you also have the ability to control those motions using the foot pedal down below that we showed earlier, and pressing these buttons initiates the action of the foot pedal. So now that we powered up though, the first thing you have to do before you do anything else is home the two traverses. So you do that by pressing the home axis buttons, which you can see are red right now, and the goal pretty much is to make all the red go away on the screen. So I'm going to push that, it's moving my traverse. I don't know if you saw it. And the same thing for the payout traverse. It moved, and what they did is they moved back to their rearmost limit switch and then forward slightly to the 0 position of the machine. If we had a recipe in here already for a given job, it would move to the starting point for that job. But since we have nothing loaded in here already, it's just going to the 0 point. So assuming you want to set up a job for winding onto this spool right here, we need to jog this so that the spool lines up with our final guide wheel that we pointed out earlier. Assuming we want to do a standard helical wind, we want to jog the position of this spool forward until the inside of the back flange of the spool lines up with that. And so I'm going to push. We have some buttons here on our traverse controls. You getting that in? Mm-hmm. So we can jog forward, jog backwards, and we also have what we call bump buttons. And these are kind of like a jog, but the difference is when you do a jog, which I'll hold right now, you can see the system is moving, and it'll just keep on moving until I let go. And that's your standard jog. I can jog backwards too. But we can also program in a very precise move that we call a bump. Okay, so each time I move or press this bump button, you can see the traverse makes a defined move. And of course I can bump backwards as well. I apologize, by the way, there's a machine operating in the background that you hear. That is not the noise from this machine. This is a very smooth, quiet machine, except for the beeping. This bump, I want to point out, the amount that moves is adjustable in our system settings screen, which we'll get to. Right now, it's a pretty big move, but you can have that move just a couple microns if you want, for very fine adjustments. It's a very useful tool on the screen. And you have the same thing, by the way, for the payoff, which we'll be working with that in a moment. So I'm going to jog, though, until I'm just going to eyeball until this rear flange lines up with that last guide wheel. And this really is, something you eyeball. There isn't a detector to know exactly when it's lined up, but you're able to tweak it later on to make adjustments. I don't know how well I'm doing there. You can see I got a piece of fiber. If I put it in there, I may want to come a little more forward. Oh, that was too much. I'll just start there. We'll call that our starting point. Okay. So now if I wanted to create a recipe and save this information, I would go into my recipe settings, and this is the take-up coil, and what we just set is the start position of the take-up coil. So to enter what I just moved to, all you have to do is press that field, and it will prompt me, do I want to use the current position? And I'll just say yes. I don't have to do that if I know already the exact number, which is millimeters away from the zero position of the traverse. I can manually enter that in. I can say no, and then just type in a value, and that will be the starting position. So if I know I need, after a few trials, if I know I need to tweak that starting point, I can take the number that's already in there and, add whatever needs to be added to it or subtracted to fine-tune that starting point. I'm not going to do anything now. I'm just going to use the number I came up with. And while I'm at it, I'm in the recipe screen. I might as well give this a name since I'm saving it as something. I'm going to save recipe as, just like a computer. And we already have a couple recipes in there. You know what? I'm going to, I can give a new name. I'll call it new name. Let's call it test. I saw there's a test 1 in there already. We'll call this test 2, okay? Actually, you know what? I'm going to call it test 4-inch. Black. So that's a 4-inch black spool. And just hit enter. So you can see the name is up there, it shows up. And so far, all we've entered is a starting position. But while we're on the screen, why don't we give it some more information? We can give it a length that we want. Just press in there and say we want to wind 25 meters. Our max speed. So this will be, the way this works is, this will be the maximum speed that the machine will wind. So let's say we want to go maximum of 25 RPM. And you'll see if I just press wind on the home screen, on the main screen, it'll wind at 25 RPM. But then I can also use the foot pedal to have complete control of the speed. If I fully depress the foot pedal, it will go 25 RPM. Okay, I can enter in here a desired tension. So say we want to wind with 25 grams of tension. The fiber diameter, this SMF fiber, I think it's about 250 microns. I'll enter that. The pitch, the fiber pitch is the actual spacing you want between each wind onto the take-up spool. I've found over the years that if I make that number a little larger than the diameter, I get a good result. So I'm going to put in 270 microns. And of course, there's no reason why you have to have perfect side-by-side placement of the fiber. You can put in there a very large pitch if you want. You can put a 25 millimeter gap per wind if you want to. The take-up coil width, so that is the width of our spool. So if you show down here, Ed. So here's my take-up coil. It's a spool in this case. It's asking for the width in here. And let's pause a minute. I'm gonna grab a ruler so we can measure that. So I grabbed the tape measure and we're gonna measure the width of this. It's asking for the value in centimeters. So that's the centimeter scale on here. And so that is, let's call it 3.8 centimeters. So we enter 3.8. The next thing it wants is the take-up coil inner diameter. And that is the diameter of the surface that you're going to be winding onto. And this is one of the most critical variables you need to enter, because the tension control is very reliant on entering the diameter of this accurately, as well as the payoff spool. It uses those two bits of information to start the tension control. So to do that, we have this tape measure plugged for Showmark. It's kind of handy. It's a pi tape, and what it does is it tells you the diameter. It looks like we're measuring circumference, but the number on there will already be divided by pi. And so using this, and we'll provide one with the machine, I'm getting 7.1 centimeters is my diameter of this surface. So I'm going to put that in. And by the way, that's the yellow side of this. If I use the white side, that's a standard tape measure. And you can see the difference here. I'll show. So this 22 is the circumference of that surface. So obviously there's a difference between the circumference and the diameter. We want the diameter. So that was, what was that, 7.2? Okay, so coil inner diameter 7.2. Are you sure, Ed, or was that 7.1?
Well, you can measure it again. You have the tape measure.
Let me try again. Bad short-term memory. So now I'm getting 7 on the money. What did I do? Oh, no, 7.1. Okay. Yeah, it was 7.1. It might be. It depends on how I hold it. Okay. If you're within a millimeter, it's usually okay. Let's make it 7.1. Okay. Lead length, it can be 0. What that would be is if you wanted to pull out a certain leader length before you started winding the main portion of the spool or coil, you can enter a value in there and it will let you pay that off first before it starts counting the main section. So I'm going to leave that as 0 for now. Take up start position we already looked at. That's where the inside of the rear flange aligns with the guide roller. Layering mode. So this is a nice feature of the machine. You can see if I press this, we have a manual mode. Ignore that for the moment. In auto mode. So auto mode is the machine just will wind back and forth in a helical pattern until you've reached your length. And of course you can pause it and control the speed and reverse if needed along the way, but it will just go to that length automatically if you want. We also have manual mode where if you know how many wraps you want to put on each layer of the final product that you're making, you can enter in here, you can create a table where you tell it how many layers you want. You know, say I want, 3 layers. And if I want, I can enter the number of turns on each layer manually, and they can be anything you want, I believe within reason. But you can also tell it you want each layer to automatically decrease by 1 or 2 turns, which is very often the case. So let's say we want to take 1 wrap off of each end. I'll say decrement turns by 2, or decrease turns by 2, and it will ask you how many turns do you want for the first layer, and let's say we want 30. I'll do that, and you can see it automatically populates the rest of the table. So it's very helpful for certain applications. Okay, so now that we populated our table for a layered winding or manual layering mode, you have 2 choices for the wind pattern. A geared pattern is simply a traditional helical wind. It'll just create call it a corkscrew or helix across the spool. You also have an option for a step wind, which is very interesting. And what that is the machine will make 1 full revolution in one place, and then step over the amount of your winding pitch, of this amount. And after that step over, it'll make another turn and step over. So it's a straight wind with what we call a jog zone across the spool. And sometimes that's desirable for certain products. So for now, though, I'm going to not do the the layered manual wind. I'm going to do the geared wind. And when I do that, it's going to clear out my table. So if I wanted to, I could save all this as a recipe, but I'm not going to. I'm going to clear it out. I'm going to let it be cleared. And so now we're back into auto mode. And in auto mode, you don't have an option for step wind. It's just geared all the time. Okay. Another thing you need to put in here, though, is the width of the payout spool. And this is needed so that if you go into an unwind mode, the machine knows how to go back and forth to layer the fiber back onto the payoff spool evenly without going into the flanges. So again, I'm going to take my tape measure and go over and measure the width and diameter of that payoff spool. So if we pause a moment. Taking my tape measure again and measuring our width, which standard Corning spool, you're 95 millimeters across, or 9.5 centimeters. While I'm here, I'm going to measure the diameter of the spool. Should be about 165 millimeters. And it is. There's that's 16 centimeters. There's the 5, so 165 millimeters, or 16.5 centimeters. So 95 and 16.5, if we can remember that. So width, I take it back, not 95, but 9.5 centimeters. So 9.5. And same thing as we did on our take-up, we want to find the front flange position of that spool. So we can leave the screen for the moment. And I'm going to use my jog buttons to align the front of that payoff spool. And you know what? It's already close. I'm going to use the position I'm in now. Happen to be there already. So let's go back to our recipe screen and put a value there. It's going to prompt me, do I want to use the current position? And I'll say yes, which happened to be the 0 position of that actuator. That's why it still says 0. It's just a coincidence. Okay, so let's save what we did. So let's hit Save Recipe, and it's going to ask, do I want to overwrite test 4-inch black? I'll say yes, because it'll keep all those values. And now I can close my window there. Okay, so the next thing we want to do now too is, if you recall the alignment array on the payoff spool, it's important that the payoff point of the fiber goes through that alignment array right from the beginning. And you can see, I'm going over here, here is where the fiber is coming from. It's off to the side. It should be between these two sensors. So I'm going to jog this spool forward until the fiber is between the two sensors. Okay.
Go ahead and do it.
So I'm just holding my jog button in. Cameraman, if you can tell me when we're there.
Looks pretty good.
Okay. So we'll stop there. And now back to our main screen. If you remember, we already hit the home buttons. And when you home, by the way, the buttons turn green and they change to these two labels. And we'll get to them in a second. But the next thing we want to do is tell it that these really are the starting positions for what we're going to make. So we want to set these as references. So I'm going to set the reference for the take-up, and that's just saying this is a 0 position. And that's the rotary position, by the way. And then same for the traverse. So everything's turning green. And then we're ready now to actually string up our fiber before we turn our tension on. You don't want to turn tension on when the fiber is not secured. So I'm going to pause.
Remind them this is loops too.
Okay, so Ed's going to thread the fiber through the machine. Takes a little bit of getting used to, but it's not too hard to do. So down through the length tracker, up down around the tension transducer, up over the dampener sheave, down around the next guide wheel, and up onto the arm. Now what I find to do that helps at this point, I don't know if you were going to do it, Ed, is, but tape the end right there so that you can go around to the other side now. So I think Ed's a former gymnast, so he can do it without the tape. But he's putting the end of the fiber through the spool we had on there, and he'll just tape it. One thing I remember is my payoff spool is still loose. I need to go over there, or Ed, will you go over there and tighten up? You need to put a little tension in it first. Tighten up, pull back a little bit. There you go. Okay. So now we're threaded up, and I'm ready to turn on tension. And the way we do that is by telling the system, you can see here we have a new take-up button or a new payout button. It's a little confusing. I'll try to explain. The purpose of the new payout is anytime you put a new spool on the payout and you're using it for the first time, you need to press that new payout button. So I'll do that. And when I do that, it flashes yellow for a moment, and it's establishing the tension we want, which is 25 grams. And once it gets within a plus or minus window, it turns green, you can see. Okay. If I'd already wound a spool using a payoff spool, and now I've just put a new take-up spool on this side, instead of pressing new payout, I would press new take-up. And what that does is it saves you a step of entering the diameter of the payoff spool, which, by the way, I never entered. Okay, and the place where you enter that is actually on the system settings screen. It's a little different. You do that here on the payoff spool diameter, and it's already in there. It was, remember, 16.5 centimeters, but you would enter that there, and
It's already there, so I'm just going to exit. Okay. Oh, by the way, I couldn't change that right then because this is already in tension mode. If I turn it off, now if I go into my system settings screen, now I can change that value. I couldn't before when it was tensioning. But I'm just going to keep 16.5. Hit enter. Okay, and again, I'm pressing new payout because I haven't really used that. But what it does is, if you've already wound a spool, you'll presumably have used up some of the fiber on the payoff spool, and it changed the diameter of that payoff spool. And if it was a very short length you paid off, it probably doesn't matter. But let's say you wound a kilometer of fiber off of there, and it significantly changed that diameter, it would force you to go in and correct that starting diameter of the payoff spool. But if you're using the same one over again, the machine already knows how it changed just from having to keep track of it while it was winding that last spool. So if you're just reusing that spool and just putting a new take-up spool on, press new take-up. So hopefully that's clear. It's easy once you understand it. So we're ready to wind at this point. So I want to say setup done. Okay, now all the red is off. And again, you can see in here, here's our recipe information. It's that's the name of our recipe. We're in auto mode for the layering. It's just a geared wrap. Here's our desired tension, length, and no leader going on here. And while we wind, it will update these fields with where we're at in the job. Okay, so now I have the option, I can start winding. I have the option just simply to press wind or to use the foot pedal. So at the moment, I'm going to use the foot pedal, and I want to wind forward, so I'll hit wind jog plus. Nothing will happen until I depress the foot pedal, so I'm about to do that. And go back up to the spool, you'll see I can very gradually start winding if I want. I have complete control over that rate. I can go faster, just like a gas pedal. And the max speed is what I had put in that recipe, which is shown here on the screen, by the way. You can see the current speed's 25. If I let go on the pedal a little bit, you can see how it changes the speed. But it's limited to a max speed of, that's not shown on there, but it's 25 is the max. Okay. And you can see here it's tallying up the amount wound so far. So that's using the pedal. If I see I need to make a correction, I can go into the jog minus mode for the pedal and do some unwinding as far as I want. Okay. You can go back and forth as much as you want. Or if you just want to wind and don't need to monitor so much, just press the wind button and it will just wind at that max speed that was in the recipe. You can see pretty nice placement of the fiber. It will be nice for a few layers. We don't guarantee that if you fill this spool up with fiber that you're going to have perfect rows and layers fully to the top. It's sort of it's a difficult thing to achieve without some operator intervention or other special equipment. So anytime I want now, I can pause and go up here, press pause, stop. I can hit unwind. Now it unwinds. And if I just let it unwind all the way, it'll automatically stop at the starting point. You don't have to worry about going back too far. Okay. So that's winding in a normal helical kind of wind. Now, if I wound all the way and I want to take this spool off I just wound, or if I just want to cancel this job, I just press spool done, which I'm going to do.
Yeah.
Okay, after you've pressed spool done, the machine will automatically bring up the report screen. And these are standard fields that we've got here where you can enter in the date, things like a model number. And when you do, it brings up a keypad. Things that may or may not be useful, charge number, fiber type, vendor, whatever, line description, you get it.
Okay, go.
If you do want to generate a report, you have to have at least a serial number in there. And I'm just going to give it a number 1, 2, 3. And if I hit generate report, you can see what you've got here. It's just basically the parameters that were entered for that recipe, as well as the date and operator name. And that can all be saved just like any file. It's a notepad file. Print it out if you want to. Okay. So let's go back into our recipe settings. And let's do a layered wind. So here I'm going to make it manual layer wind. Going to give it a number of layers. Let's again give it 3. And we'll have it automatically decrease the turns each layer by 2. And let's start with, let's say 40 turns on the first one. You can see it populates 40, 38, 36. So let's close that window. And we'll wind with that. So again, a new spool or a new coil being wound, we need to set our references. So let's just call each thing 0. You know what, I'm gonna undo that actually for the moment. Something that is important to know is, you know, say on the previous wind, the position of the spool is not where it needs to be to start the next one. So I happen to unwind all the way back to 0 on the previous wind, so it is where at the beginning point. But let's say I'm just going to jog it out of position. I'm going to bump it back a few times. And so now I'm not lining up with my flange. But remember, our starting position is in our recipe, so I can tell the system to go right to there. And to do that, if I just press and hold the go to reference button, it's prompting me, hold 3 seconds, and it will automatically move to the right point. Something that's important to know. Okay, so now we're ready to start. And again, I'm going to set my references. Just tell it, okay, I am at 0. And now I can, I'm going to press new take up, because we already wound using the payoff spool before. It knows the diameter, just having registered the tension while it was winding. It knows what to do with that payoff spool. Okay, and so now I have the option to tell it whether I'm going to wind a left to right on my spool or right to left. I'm on the left flange, so I'm going to keep it there. And I'll say setup done. And again, I can use my foot pedal or just press wind. I'm going to press wind and let it do it automatically. And it's going to turn 40 times. And you can see up on our screen, right, here's our revs. So when this gets to 40, it will stop. And it's reiterated here that we're required to have 40 for this recipe. Go a little faster. Yep. I can't stop it now and change the speed, so let's hang on a minute. I'm going to pause. I don't think I can change them. Let me see. Recipe setting. Yeah, I can change the speed here. Let's go 60 RPM here. Make it go faster. Okay. And hit wind. So we're at 25 turns. Just about 40, and it stops by itself. Alrighty. Hey, and while we're at it, our camera is on. Let's position our camera over that. And you can see here up above, those are our winds. Okay, and put my hand in there, you can see real time. So a nice image from the camera. And by the way, this software that comes with the camera allows you to store those images. You can keep those for documentation or whatever. Okay. All right. So now we just finished the first layer of our manual wind. You need, as manual implies, to tell it we're ready for the next layer. So I'm going to press next layer. So now it's going to go from right to left, and that even changed the button above there. So when I press wind, it's going to do 38 wraps this time, go in the other direction. It's not going to automatically move over one wrap of the previous layer and perfectly give you 38 layers on top of that. This is where it will take an operator probably to have some sort of tool in their hand. I don't have anything in my hand right now, but you're going to need to, carefully, this is where the jog pedal comes in handy. If it needs to be precise, to use the pedal and the tool to get you over that first wind. And use your camera. I'm not actually at the very end of it. Let's see if I can get there. There.
There you go.
I wasn't prepared to be right on the right spot, but you get the idea. You can move the camera to exactly the right point. Okay, so I'm going to continue here on this layer. And I think I did jump up the next layer, and we'll do 38 winds across the other way. And now I can let up on the pedal and just hit wind if I want. I could have backed up if I needed to make a correction too. You can do anything. This may or may not be perfectly placed, relative to the bottom layer, but that was pretty good for not trying too hard. Okay, so we finished the second layer. Now we're ready for the next layer, which is the third. I press that, it jumps left or right, and we're going to do 36 turns on this next one. So again, I'll go use my foot pedal, and I'll try to... I'm not sure if I'm in exactly the right spot. A little magnifying lens in addition to the camera would be helpful. I'm probably over too far, but we'll let her wind on her own. Okay, so it finished that third layer. Now, one thing to keep in mind when you're in the manual mode is that when you press unwind, which I'll do right now, it will only unwind to the previous layer, and you can't go any further back. So once you finish a layer, you have to be sure you want to move forward. That's it. I'm going to pause right there. Okay, hopefully that was a good overview of the main screen and entering a recipe. I'm going to go through here in the system settings screen now wait, before I do, I'm going to say spool done, because I can't access a lot of those things until I say spool done. It's going to prompt me, do I want to create a report? I'm going to say no, I'm just going to cancel it. I don't need a report. But we'll go into the system settings screen. And these are a lot of global variables and settings just for operating the machine as a whole. I'll go through each one. The payout spool diameter we already looked at, and that's important. You know, anytime you start a new job, you have to have that spool diameter in there. Take up bump amount, that's that amount that the spool will rotate each time you press the bump button on the take up section. And there's also the acceleration of the take up can be entered there. These are probably values that you might not want to change. They work pretty well by our settings. Tension gain, correction, and fault limits have to do with the tension control and how responsive it is to an error in the tension. And again, these are pretty tried and true values that we have here. They can be played with, but you may want to make note of what they are before changing anything. The take-up traverse forward limit is just the maximum distance that the take-up traverse will move from the 0 position. The traverse home speed is how fast it will make that homing move. And usually it's a pretty slow number or amount. And the reason is you want a very accurate homing routine to give you a very precise reference for starting. And by the way, you see a negative number in there, which will tell it to move backwards first towards the rear limit switch, and then turn around and come forward. And we usually have a negative number in there. Take up traverse move speed, that is, I believe, related to the jog speed for the take-up. The take-up traverse acceleration rate is just how quickly it will make a move. And then the bump amount is, again, just how far it will move each time you press bump on the, each time you press bump on the take-up section. On this side, similar to what was down here, but for the payout section, you have the forward limit amount, the furthest it can move forward. The move speed, again related to the jog speed. The acceleration amount for the traverse of the payout, just how quickly it comes up to speed when it needs to make a move. And the bump amount for the payout. So just like on the traverse, you can set the bump amount. This section here is when you are reaching your target length, you're able to set up the parameters that the machine uses to come to a stop. And so you have two slowdown points. You know, one is what we call auto stop slowdown position, which is, in this case, when you're 1 meter away from your final length, it will begin to slow down to this speed, which no matter where you were while you were winding, it will slow down to 15 RPM. So that is the slowdown speed. But then as you get even closer to your final target length, you have what we call our creep position, which means when you reach this point, in this case 0.1 meter away from your target, you'll go into this even slower creep speed, which we've got set for 5 RPM. So that's, you know, sometimes depending on how fast you are winding, you may need to tweak those things. And then start position, reference adjust amount. That's, if I go here to my main screen, I didn't explain these buttons. So these reference buttons here are, if you're winding and you notice that you're not quite getting to the flange or going too far into a flange, you can press these buttons either way to adjust that home position, that inside flange position. And the amount that adjusts for each press is set right there. So right now we've got it set for 0.1 millimeter or 100 microns each time you press these buttons, you will adjust the turnaround points of the machine. So it's adjusting the home position, and then based on the width that was entered for that spool, that turnaround point is changing as well. So it's shifting the window of winding. That's basically what it is. Then the last screen is report settings. You saw that. And you can just generate a report anytime you want. One last thing to point out are these two boxes here, left and right. All those are is, if you remember on our alignment array, each time the fiber passes through one side of the array, those will light up. So here, I'm going to grab the camera. Ed, go over there and just put your finger and block the array. You see, and then do the other one. Okay, so he's over there, and if the fiber were crossing over there, you would see that those lights light up. They're really just a reference to confirm that they are working. Last thing we'll do is just show how to shut the machine down. And first thing you can do is turn off the camera light, which is right here. And then use your screen here to shut off the PC. You can close your program. It'll prompt you, are you sure? Yes. And then you can squeeze your finger down here in the corner, get your start button like any computer, hit your power, shut down, and that'll just turn off. You can turn the power off behind the screens, just like we showed earlier. And then last thing is the main power for the whole machine is right here. Okay, and also didn't show, but so there's a lot of plugged in devices on here, but we've got a convenience power strip bolted onto the frame of the machine. So most of those things are wired into there. There are, if you turn to the right there, Ed, 2 plugs for the machine. You got your main power, and then the other one is that power strip.